We extend our heartfelt gratitude to Dr. Hugo Gamboa for his enlightening talk on making sense from biosignals. Dr. Gamboa, your insights have shed light on the potential of biosignals in advancing healthcare and technology. Thank you for sharing your expertise with us. Your dedication and insights have been truly impactful. We are grateful for your presence here today. It is my pleasure to introduce Mr. Pandeyarajan, an application specialist at Delsis, Bangalore. Starting his journey as a physiotherapist, he gained hands-on experience in clinical practice, helping patients with neurological impairments. Over time, his passion for innovation led him to explore digital health and wearable technology, bridging the gap between healthcare and engineering. Mr. Rajan has worked with experts in sports science, rehabilitation, ergonomics, and human-machine interaction using advanced EMG technology to improve movement analysis and performance. His work has contributed to cutting-edge solutions in muscle monitoring, injury prevention, and training optimization. Today, he'll be sharing insights on beyond EMG, motor units, and applications of high-density EMG, helping us understand how this technology is shaping the future of movement science. Let's give a warm welcome to Mr. Pandeyarajan.
Good afternoon, everyone. So, I hope everybody is hungry. It's almost like 1:10. I won't take much of your time. Just give me like 20 minutes, max to max. I'll try to wrap it up with the scheduled time, okay? 1:30. And thank you for the introduction. So, myself, Pandeyarajan, and I have a background in healthcare. I'm a physical therapist. I did my, let's say, like quite 4 to 5 years of clinical practice. Then I found it like the technology is not accessible. So that's where my passion for technology began. So then I moved into like movement science division. It's a emerging, let's say, like trend in India, I would say. So I found an opportunity. I started working in the particular division. So I started setting up labs for, let's say, like IITs, NITs, all the top-notch institutions in India. So that's how I kind of look into sales and application support for India. So I joined Delsis back in 2023, let's say like 1.5 years into Delsis. So I'll be talking more about EMG, and thank you for laying the foundation for EMG as well, like as a biosignal. So that gives me like easy. I can convey my message, whatever it is. So we will be talking about motor units and as well as application of high density EMGs. But before we get into that, we need to, let's say, like talk about a couple of things. Do you see the activity, right? So as an individual, I'm standing here because whatever we do as an individual, it's a combination of muscle involvement. It's a collective movement. If some of my muscle is not working, that's paralysis, or whatever it is, you name it, okay? So to be able to walk, I need a coordinated muscle activity, right? So that's what we do in Delsis. It's just that meaning we produce, I'll come to the next slide, okay. So we have muscles, how does it control? It controls through by brain. That's a command center, like that's where the EEG signals comes into play. So EMG is a indirect measure for EEG as well. Okay. So Delsis, we are the world leader in terms of manufacturing wireless surface EMG sensors. Okay. So our company is based out of Boston, US. EMG is not a new technology. It's a very age-old technology. It's there in like for ages, and we are involved with EMG for about close to 5 decades now. Our founder is Professor Carlo J. De Luca, who was the pioneer in motor control biomechanics. He started off his research back in 1970s, and we officially emerged as a commercial entity company in 1993. So our products are like patented, And I'll show you those applications as well as we move forward. So electromyography is nothing but the study of muscle. Whatever the electrical signals are generated, we are just going to capture it with the help of sensors. So there is a book called, if you are interested in learning more about EMG basics and to the advanced level, you can read this book called Muscles Alive. It was written by Professor Basmajan and as well as Carlo J.D. Luca. Okay, and as I mentioned, like I am a healthcare background guy and you're all engineers, right? So as an engineers, you are producing the, let's say like technologies for the use of, let's say like people, common people. So this is a quote by my professor, which is our founder, and engineer is the artist of technology. So you are molding your expression depending upon the use cases and you are creating a product and you are making it utilize or accessible to a common individual. This is our years of innovation of the EMG technologies. If you go back in time, EMGs are like completely wired technologies. Then as we move forward, we come up with wireless EMG technologies. Before we get into the like actual thing, I'll just show you a couple of the technology which we displayed today. So this is basically the hub receiver base station. Then we have varieties of EMG technologies, which means the sensing units. Depending upon the use cases, the sensing technologies will vary. Then we have created like integrated with couple of physiological sensing units because we are not commercially available for common people. We are commercially available for research purpose. That's our portfolio. Then we also integrate with any of the motion capture force plate, like any companies in terms of movement sense division. Okay, so where our technology will be utilized? It can be a basic research, applied research, transnational research, or even in terms of educational wise. You can use our technologies. Then applications, where all you can utilize engineering, neurophysiology, biomechanics, ergonomics. Then application of EMG in rehab, robotics, or in other words, let's say like assist devices. So how do you utilize? What value does the EMG provides? Let's say in terms of prosthetics, it gives you the natural movement replication. You can use it as a evaluation tool or you can use it as a control mechanism. That's depending upon like what's your research scope or what's your objective, right? So it can be utilized in upper and lower limb prosthetics, those applications. Then wearable robotics, then musculoskeletal modeling. I have a small video to explain all of this. These are all done by our clients who are all using our equipments. So this is in a lab where the individual is wearing an assistive device, which you can see, the prosthetics. Then this is musculoskeletal modeling, trying to replicate to get the accuracy of into the digital modeling as well. Then this is a company called HeroVear. They have created an exoskeleton and the EMG sensor is being utilized to study the effect of low back muscle activations. Does it actually reduce the muscle involvement or not? Then this is again for some rehabilitation applications where for the fine motor activities, they also look for the tactile feedback as well as muscle activity. Then if you guys are interested, if you want to learn more about this, you can go through any of those research articles. I'll be leaving the presentation right here. You can collect it from the team. So you can also go to our Delcis Scholar website. Wherever the research is being done with the help of Delcis, you will find all those relevant articles there. Then I can also give you a couple of open source resources available that all contains Delcis EMG datasets. So you can utilize it if that's needed. Then in terms of human-machine interactions, it can be used, like as I mentioned previously, like EMG, you can use it either as an evaluation tool or control tool. Right now it's all about, let's say, like control mechanisms. You can use it in pattern classification, like gesture recognition or anything. then intent detection, then shared autonomy. Again, I have one more video to like explain this in a quick way. So you see an individual who has a EMG sensor on his hand. He is completely paralyzed, but this is just a basic activity. This will help him in the ADL activities. Let's say if he wants to grab a glass of water and drink it. That's how that can be utilized. I didn't show the complete video of the particular project, but I have it played on the outside. You can come and watch that. This again, like validating the exoskeleton, like using EMG as a control mechanism for the exoskeleton. It's a soft robotic exoskeleton. Then again, it's more in terms of ergonomic involvement. This is for prosthetic. So with the help of like one of the Galileo sensor, they are trying to control a prosthetics. This is where the shared autonomy comes into play, like say like some hazardous environment where the human intervention is not possible. You can stay out of the hazardous zone, control the particular cobot. That's how you can again utilize EMG technologies. Again, couple of applications available, you can read it. Then again, for those open data source available. Then application of EMG in extended reality. So in terms of digital twins, yes, can you use it? We are the only company to provide, let's say like pipeline to Unity interface in terms of EMG. So biosignals can also be utilized into EMG. Into XR environment to give more of, let's say like the feedback to an individual that gives them, let's say motivation or courage to complete a particular activity. Then in terms of telehealth, yes, you can utilize it. Then telehealth, it's more about, let's say like remote patient monitoring and stuff like that. Then human computer interaction, I'm not sure how many of you have read about Meta's EMG wristband. So Meta has a Meta Reality Lab, that's the research wing. They have done like quite investment into human computer interface in terms of healthcare applications. So they have come up with the AR glass, which is named as Orient glass, I believe. They also come up with the EMG wristband. To interact with the virtual environment, they are just using, let's say like EMG signal, just by, assume you have a keyboard, you're typing, but even without keyboard, you can type and interact in the virtual environment. Does it have any impact into the healthcare application? That's their focus. They have started their work back in like 2017. They have completed the prototype in 2020, early 2020. Then they have officially commercialized the product in 2024. So there is a number of research publications available in Meta Reality Labs. You can even go through that if your scope of practice like extends to human computer interactions. And again a sample video. So the development of the Unity interface, it depends on application you will develop, but the data is provided by EMG signals into the particular environment. This is more about like pattern recognition. It's just that all of it just takes an input from EMG signal and giving it to them. This again one of the rehabilitation setup. We are just trying to motivate him to do like complete the activity. Like not being a physical therapist, me, like if I prescribe someone to do some exercise, they will not complete it. So that's where these technologies comes into play to make it more interactive, engage And again, couple of research publications available even in terms of extended reality applications. Then the must check out for extended reality, if you are exploring, TARS tutorial that was developed by professors from Wright State University, and again that was funded by our non-profit organization, which is DeLuca Foundation, in the name of our professor. Now comes like high density EMG. So EMG, like we have varieties of sensor, as I mentioned in the previous, shown in the previous pictures. High density is, we need to know the basic physiology of it. I'll just keep it very simple. As I mentioned, like our command center, which is brain, sends out the signal, then it goes to your spinal cord, from there it goes to your particular muscle. How does it do? So from spinal cord, it sends as a motor unit, then number of motor units are responsible for number of muscle fibers contraction, right, recruitment. So those are the motor units we will try to look into in terms of using high density EMG sensors. But when I use a normal, let's say like conventional EMG sensor, we will be only seeing the summation of the action potential, which is the EMG signal which is on the right top corner. You will not be able to see the motor unit firings if you are using normal EMG sensors. Again, there are a couple of algorithms being developed, there are technicalities involved. Everything, if you want to like know the differences, I have the sensor, I can show it there. You can come and check in the booth. So Neuromap, this is the specific sensor called Galileo. This provides you the motor unit firing informations. When you collect the data, it's basically a EMG signal, but we have a post-processing software where it will give you the motor unit level information. How many motor units are responsible for particular particular muscle contraction or particular movement. Because our brain does not remember any muscles, it only remembers the movement, right? That's how the brain works. So to get to those, like these sort of advanced sensing technologies are needed. Again, over the period of time, only the algorithms evolved, right? So in terms of neural interface, the algorithms evolved. They first started off with EMG like aggregation, then it had like latencies. That was the problem. Then they started looking into particular motions to try to replicate it. Again, that had its own drawbacks. Right now, it's more about combining both of these and coming up like using a deep architectures. That's where you can do a, let's say like you can control a particular prosthetics and it can replicate easily. As you have seen on the other video, like he's doing a particular movement and the cobot reacts to it without any latency or delay. That's how only the evolution of algorithms has been there. This is again a study with the usage of Galileo sensor. The individual is amputated and they wanted to like put him on a myoelectrically controlled prosthetics. And they wanted to like study the difference between unaffected and affected side, both the sides. So if I put the sensor on my affected side, I'm getting the motor unit information, but there is a direct correlation with the brains. Like cortically, the informations are changed. It's not the same as if for the unaffected side. So again, these are like challenges. Couple of ongoing researches are going in this particular segment. Again, you can read those article. I have given the reference. Then using EMG as a clinical biomarker. Like again, what are the studies I am showing? It's all like I have not seen in India. That's why I'm presenting those studies. And even if somebody has started working on it, it's all in the preliminary stage. They have not started working on it effectively. That's why I'm showing these couple of studies as a reference. Then clinical biomarker, it's more like they have started the study on developmental communication disorders. Does it has any effect on the motor functions? Like in terms of, let's say like any sports or any communication skills. Does it has any impact? Yes, it has impact. Again, I'm giving the study reference. You can go through it. Then ACL rehabilitation, it's one of the common problem in sports injuries. And every time the protocol for ACL rehabilitation evolves, but the chances of recurrence of the injuries still remains the same. So can we utilize high sensing technologies to like note down the difference between affected and unaffected chain motor unit information? Can we improve it? Because most of the testing done in the static environment, which is lab based, but assume a football player. If I am testing him on a static, which is lab based environment, when he goes into play on the ground, he will have recurrence of injury again because he is not being trained on the particular dynamic environment. That's where these wireless technologies comes into play. You can take it on field and test it. Then comes the advanced sensing level technology, which is Trinio maze system. So it's completely a spatial mapping rather than a single muscle focus. Right? So where it can be utilized, you just put on the sensor. It gives you the spatial information of wherever the sensor is being placed. It's not about a single muscle. It can be placed anywhere. That's the use case. Like where can you utilize it? Like in terms of pain, yes. Fatigue level, sports performance, diseases, intervention, you can utilize it. Then in our Delsis Europe office with the collaboration with Manchester Metropolitan University, we have done a study in terms of like adjusting the seat height of the cyclist. Can it have any impact? Yes, it has a lot of impacts. So if somebody is like going into fatigue stage, that's when the let's say adaptive mechanism comes into play. Then is there any prolonged effect? Can the adaptive mechanism convert into injury? Yes. So it's again in the preliminary stages of the research. There is a lot of ongoing research in the cyclist. Again, if you are interested, you can explore these technologies as well. Then that's it from my side. As I mentioned, I have completed within 30 minutes. I try to wrap it up. If there are any questions, please let me know. And I will be available for the 3 days. You can ask me. If you would like to connect with me, you can scan this QR code that gives my information. Yes.
Like ENG with EMG.
Sorry,
ENG.
What is mean by EMG?
Neurological.
Okay, EEG you're talking about.
ENG.
Okay. So we have integration pathways available, but it depends on like what sort of integration pathway you're talking about. Let's say we have in terms of hardware setup, we have BNC cables. If your other device also has an BNC cable, you can do that. Or else we can also think about, let's say, like some converters, BNC to some other converters. That's the option we can think about in terms of time synchronization in hardware. But if you're talking about, let's say, software level integration, we provide our Delsis API so that you can like use it on Python, C#, Unity, MATLAB, wherever you want. That option we are giving. So it depends on what's the other technology you're talking about. In terms of movement science technology, motion capture, force plate, instrumented treadmill, EEG, those integrations already available, we can help you. But if something is not available, we need to find a way to work this out.
So there's a possibility that we integrate with, so you are specialized in EMG sensors and acquisition of EMG sensors to the software.
Yeah.
So right now we have high density EMG and all those things.
Yeah.
So along with that, if we want to correlate other signals like ECG and EEG, we may have to get the sensors available for that, and
Yeah.
there's a possibility that integrate to those sensors with the Delsis system and correlated information we can analyze.
Yes.
Okay.
There is always possibility. It's just that everything cannot be given as a digital integration. Something can be done as a analog, then something can be done as digital. Then you get all the data. So if you only look for one option, then nobody can provide. That's where the technology evolves. As a company, we are also evolving.
So as a company giving that as a knowledge base, that's a good idea actually, because maybe the founder has the professor background,
Yeah.
he is sharing the information available as a knowledge source.
Yeah.
And so I also used that extended reality based that open source
Yeah.
library to integrate. Maybe soon we may procure Delsis sensors also
Sure.
and make the studies, and we can showcase
Yeah,
in the future
de-
some of the
definitely. Like,
slides.
I'm just
later.
trying to showcase some of the Indian studies to
Yeah.
abroad people as well.
I think
But
we'll come back.
yeah.
We'll come with that. We are planning to set up a biomechanics lab probably along with you, and the next time I'm sure you will show some slides.
Definitely. I would love to do that, because like I can say my US team and Europe team, like we have a so and so facility there and they are doing a good job. Why don't you like show it to them? Yes, we can certainly do that.
Thank you. Thanks for a lot of support shown.
Yeah, thank you. Thank you.
Thank you, sir, for an engaging and insightful session. Your expertise in EMG technology and movement analysis has given us new perspective on how science and technology can work together to improve performance and rehabilitation. We truly appreciate your time and look forward to seeing how your work continues to make an impact. Once again, thank you, sir. And now we break for lunch, guys. Thank you.